This video demonstrates an activity which I recently completed with my Year 12 class, and in that activity we positioned pictures of all the students in the class onto a sine wave, and we manipulated those images using rotation, dilation and enlargements. I did not wish to put the images of my students all on this video, which will be displayed on the internet, so instead I've just inserted some pictures of clip art, and I'm now going to show you all the list and sequence commands, which allows you to carry out the transformations on all 6 of these images at once. When we did this in class, we actually did it on all 19 images at once. Okay, so first note the names of these are pick 3, pick 2, pick 4, pick 1, pick 5 and pick 6. Alright, so the first thing you need to do is create a list of those names of those pictures, and that'll be list 1. Okay, and then the second thing I did was create a list of points which were the lower left hand corners of every image. And then the third thing was to create a similar list, but this was the lower right hand corner of all the images. I'm going through this pretty quickly, but you can pause the video if you wish and study the commands. Alright, the next thing that I did was to create the midpoints at the base of every image, and the midpoint of the 2 corners, that is. And then I defined the sine wave in terms of sliders A, B, T and C, and you can see that A controls amplitude, B affects the period, C will translate the whole graph up or down, and T translates the entire curve horizontally. Alright, then I needed a series of points on the curve to which I was going to attach the images, so that's this command here, and I'm going to just call that list 5 just in case. Alright, enter. H moves all those points along the curve, and W changes the step or the distance in between those points. Okay, then after list 5 I needed to do list 6, which was a series of vectors joining the midpoint of the bottom edge of every image to the point which I'm going to attach it to on the curve. So that's this command here. And then this 7 is enlargements of all of those by K. Press enter and just then change the value of K to get your enlargement. If K is less than 1, of course that'll be a reduction in size. And then list 8 was to rotate each of those images around its midpoint on the lower edge. That rotation command that I just had up there, I'll put it back up again. This one here, it rotates it by slider alpha and also the arctan of the derivative at each of those points. So we can do that sort of stuff, as well as have the images, when I translate them in a minute, they'll be parallel to the tangent of the curve. Alright, so I better not do that one again, just delete that. And now there's one command to go, and that is the translation of those rotated and dilated images onto the curve. So that's that one there. Alright, so if I go into object properties and hide a whole lot of these images and lists that I don't want, there's only one list that I want, and that's the last one, so I'll turn the rest of these off. And I don't want any of those images to be visible, except for that last list of images Okay, so there you go. You can now muck around with this, change the period, move them out of view, either that way or that way, and then you can spread them out along the curve, translate the entire curve so they look like they're going up and down a wave, and then you can enlarge them, and you can rotate them as well. And while all this is happening, of course, one of the best things, or most effective looking things you can do is turn the trace on, and then you can create collages of those images as they're being transformed and moved around. Anyway, press Ctrl F when you want to get rid of your trace, and if you have to, turn the trace off again to get rid of those collage effects, which didn't seem to work then, and try again. Okay, anyway, so I hope this has been useful. It was a very interesting way for the students, especially when they see their own images on the screen. They really love it, and it's a good way to get them motivated and interested in the characteristics of a sine wave and also the calculus behind all of this. Anyway, thanks for watching.